Welcome to our today's lesson. My name is Mwalimu Sam Nyamu. I request that you subscribe to the channel so that you don't miss out on any other important videos or lessons when I post. You can also share with your friends so that together we build an ocean of chemistry. In our today's lesson, we shall be looking at the inert or the noble gases, and these are basically the elements that belong to the period to group 8 of the periodic table. The objective of the lesson is that by the end of the lesson you should be able to mention or state the physical properties of the inert gases, as well as the chemical properties and also uses of some of the inert gases. Like I've just mentioned, the inert gases are usually made up of elements that belong to group 8 of the periodic table. The members include helium with the list of the atomic number, followed by neon, then argon, and then we also have other members that include krypton, xenon, and radon. The reason as to why I didn't include this one, they are not included in my periodic table, it's because they are heavy, or they have higher atomic numbers and therefore do not appear among the first 20 elements of the periodic table. So for the first 20 elements we have helium, we have neon and argon, and these are the elements that we'll be looking into as we go through the clip. And on the atomic radius, like you can see from the diagram here, from the periodic table, as we go down the group, as we get down the group, the atomic size or the atomic radius increases. Why does the atomic radius increase? We will look at, to be able to understand that one, we will just look at the atomic structure of maybe helium, and then we draw the atomic structure of argon. So for helium has an electron configuration of 2. This is helium, while argon has an electron configuration of 2, 8:8. So if we were to draw the atomic structure of helium, it would look like this. We would have helium, then the first energy level being occupied by only 2 electrons and it's full. If we were to draw the structure now for argon, we would have argon, and then the first energy level with 2 electrons, the second energy level with 8 electrons, and then the last energy level also with 8 electrons. Then we'd fill it like this. We would have the first one, 2 electrons, then the second one, 8 electrons, and then the last energy level with 8 electrons as well, and that now gives us the atomic structure of argon. If you compare these two elements, the radius, the atomic radius of helium cannot be compared with the atomic radius of argon. Remember that the atomic radius is the distance from the center of the nucleus to the outermost energy level, and therefore for argon it is much bigger, because down the group, as we move down the group, there is increase in the number of occupied energy levels. While helium has only 1 occupied energy level, neon has 2 occupied energy levels, and argon has a total of 3 occupied energy levels. And as a result, the size of argon is much bigger compared to the other 2 counterparts. We look at the melting and the boiling point. Every time we explain the melting and the boiling points, you cannot explain them without mentioning the bonds. So but basically all the elements in group 8, which we are calling the noble gases, are usually made up of molecular structures. And being molecular structures simply means that they do not, as the size of the atom increases, the forces between atoms also increases. And for that reason, as we go down the group, the atomic size is increasing. We are saying that neon has a smaller size, and then we have, for example, argon here, which has a bigger size. So as the atomic size increase, there is also increase in the molecular forces of attraction. And as a result, argon will have a higher melting and boiling point compared to neon. We look at ionization energy. Ionization energy, remember, is the energy that is required to remove an electron from the outermost energy level of an element of an atom in gaseous state. So for this case, though the reason as to why we say that the inert gases have low activity, they do not react readily, and actually they are called inactive because at normal circumstances they do not react. It's because the energy that is required to remove an electron from the outermost energy level is very high. The amount of energy that is that can remove an electron from the outermost energy level of the inert gases is very, very, very high, and as a result, they may appear to be inactive or unreactive. But we shall be seeing whether these elements are able to react when we will be discussing the chemical properties in a short while. And here we are. So the group 8 elements are seen or said not to be reactive at normal circumstances, which is true. But then when we have very high temperatures and at very high pressures, elements like xenon, the xenon is able to take part in some reactions. This is because the high temperatures are able to supply the atom with sufficient energy that is required to lose an electron. So we don't have very many chemical properties that we can study under these elements, the group 8 elements, simply because they do not react with other elements at normal circumstances. We finally look at the uses, and among the uses, like you can see, argon is used in the manufacture of light bulbs because it is chemically not very active. So for example, in those filament bulbs, when we have argon, it provides an inactive atmosphere or an inert atmosphere, so that now even when the filament is very hot, it does not burn. Then we have helium, is non-flammable, light gas, and hence preferred over hydrogen in meteorological balloons. So you note that the meteorological balloons, when we inflate a balloon using a gas that is very light, it has the tendency of just getting into air, or just moving upwards through a property in physics that is called the Archimedes principle. And therefore, for the reason that it is not flammable, it is actually preferred in meteorological balloons, where initially hydrogen was used, but then remember that in case of fire, hydrogen burns explosively and could cause a lot of harm when used. So helium is usually preferred. Then we have helium is also used as in gas-cooled nuclear reactors due to its low boiling point. The boiling point of helium is very, 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 very low, and therefore in nuclear reactors, the gas is usually used as a coolant. Then we have the mixture of helium and oxygen is used by deep sea divers, and then we also have used in inflating the aeroplane tires for the same reason that it is very light. Remember that materials that are used in making an aeroplane ought to be very light, and helium passes that test, and also it is not flammable. So unlike hydrogen, in case of fire, helium will not cause a lot of harm in such a scenario. And then finally, helium is used in the manufacture of low temperature measurement thermometers. This is because of its low boiling point again. These are not the only uses of the inert gases. You can research for more, and that brings us to the end of the lesson. I kindly remind you to once again subscribe to the channel and share this clip with your friends, so that together we build a notion of chemistry. Thank you.